As Andrew introduced, I will talk about sort of our way from idea to product, at least the way we did it in Newtrax. Bit of introduction: Newtrax is a company that does IoT for underground mines. So my talk will be more specific about underground in general, but I guess some of it could apply to open pit as well. For myself, I'm a team lead for NAI for Newtrax since 2 years ago. I've completed a PhD in mathematics, and before that I also did mining engineering at the Polytechnique here in Montreal. So quick safety share before we start. Well, you know, now with obviously I'm going to talk about the corona. With the nice weather coming out, I guess, depending on which hemisphere you're in, but at least in the north here, spring is coming and it's getting now nice out. And so it'd be easy to sort of forget about the social distanciation, but you know, let's keep the effort so that we can all go out of this confinement as soon as possible. So speaking of confinement, I thought today I would take you into a trail because we probably all need a good dose of fresh air after being confined for, you know, months for some of you. And so I'm going to take you down the Dunning-Kruger Trail. So tie your shoe, get a bottle of water, and we'll just jump in. So the Dunning-Kruger effect, for those of you that don't know, if we look at the topography of the trail right here, is this effect that have been characterized by obviously Mr. Dunning and Kruger, that more or less states that the less you know about something, the more you're likely to think you know everything. And so you first, like when you start anything, any science project, you start to learn about things, and then you say, well, that's easy, you know, I get this. And so that's where you hit the peak of Mount Stupid. You think you know everything, but in fact, you actually know nothing. And then the more you learn, the more you go down the valley of despair. And then you hit rock bottom when you realize that you actually knew nothing in there. And so from that point on, you go up the slope of enlightenment, and that's where you start to really understand the more you know. And you'll notice that you'll never get as confident as you were at first when you were on top of the Mount Stupid. Now I'm pretty used to walk around this trail. I've done a PhD, and that's the typical curve of any PhD student. I've also done this thing with the ML, as we're going to talk about. So I got my season pass up that trail. So the steep climb to Mount Stupid, specifically for ML projects, and I know some of you might be much more advanced than that, but you know, when you start an ML project, or when you want to implement it first, your ML, you look online and then you see all those like nice talk, all those blogs, and you get maps like this. And so you figure out that this artificial intelligence thing is easy, right? You just, you know, you have a map like this, you just pick the right algorithm, and boom, you get your solution. I mean, it's intelligent. It'll figure out the way to find your problem. And so that's it. It's a really nice feeling to be up there, up the top of Mount Stupid. But you know, as you know, you start to get down as soon as you get in the project. So you've decided what was your algorithm. You go from there. You're confident, and then you start. And that's when you start to go down the valley of despair. So when you choose your algorithm, you saw the world just like in the Matrix. You see numbers flowing everywhere, columns of numbers through the walls, and you think that you're going to get everything, every data you want. But actually, your data probably looks like more like this. And so you realize that, you know, all the nice information everyone told you had, and like everyone told you that you had millions of terabytes of data, is probably a lot less clean than you thought, and also you probably don't have everything you need. So that's where you hit the first 80-20 rule. So every data scientist should spend 80% of the time on pre-processing and 20% on the actual analysis, or, you know, all of the algorithm. But that's fine. You're not too bummed out because you've read about this on some data science blog, and you were prepared for this. So you spent a lot of time preparing, and it's fine. You don't get all the information you want, but you still, you're still in good shape. So then you start training your algorithm on that data, and you find out that, well, maybe the results are not as good as you're expecting. You're not getting a 100% fit on everything, because as you know, it's always a sort of a balance between underfit and overfit. So maybe you're training your data, and underfit is basically not having a good relationship, just like here. And overfit is being so good at predicting your training data set that when you actually test in the real world, it doesn't really represent the real effect. So the balance is in between, and obviously, nothing can be perfect. So your accuracy kind of drops down. But that's also fine, because you've also read about this other 80-20 rule that say that 80% of the available data should be used for training, while the other 20% should be kept for validation. And so you've kept a validation set, and your expectation for the accuracy sort of went down because you realized it was more complex than that. But that's fine, it still works. So you move along, and now you got your data set. You've read about it on for data science. You got this nice overview, so you see you're pretty much done, right? You got your data. You spent 80% on your time on processing it. You chose your right algorithm. You put your testing data set in there, and now you're good to go, right? There's only those like yellow squares here. So once you have this, once you have this, it must be easy, right? To move, you just input your production data into your model, and it spits out prediction, and there you have a product. Well, actually, not really. So here's a graph I like to show. It's from a publication from the guys from Google, and it really shows that the fun part, like all the ML code and all the nice algorithms and what we all like to do, is actually a very small part of an ML project. It's actually probably the smallest part. I know in here, well, there's a data validation, collection, and verification, but there's also a whole lot of other things that needs to be considered in your ML projects. So that's where you hit the valley of despair. So in here, if we look at what's in the valley of despair, well, on your way down, you realize that you didn't have enough data to get the expected results. Maybe you don't cover all the cases. The data quality is, it's compromising your results because you thought you'd get perfect data for everything, but you realize that 50% of what you have should be kept away or somehow massaged down. The model accuracy is not as good. You thought you'd get 100% accuracy, but now it's much lower than that. The IT infrastructure is exploding. You need a lot more IT work than you ever thought. And when you start getting more and more data, you realize that there are more edge cases because, rather than, if you look on Kaggle, there's always those good data set. Kaggle, for those of you that don't know, is this website that proposes sort of challenges in AI. And so there are a nice data set, and then there's a problem description, and people give it a go. And so they try to solve this problem. And the thing in those is that the data sets are always super clean and good, but in real life, when you get live data and the real data is coming in, you will always find surprise, and there's always something new that you never foresee. So those edge cases would also play with your accuracy, and the scope is growing out of proportion. So now you hit despair, you think you're never gonna make it, AI anyway is useless, you shouldn't have gone in there, but there's a way forward. And so toward the slope of alignment, you need to remember yet another 80-20 rule, or maybe it was all the same, who knows, stating that 80% of the effect comes from 20% of the causes. It's also known as the Pareto Principle. And so it means that if you put your effort in the right place, it should give you most of the results you want. And so toward the slope of alignment, my advices are that start with the easy stuff. If, like starting with the principle of the 80-20, 20% of the effort, the simplest stuff should give you everything you need. And so, or not everything you need, but at least 80%. And so it will, on this way, will increase confidence and also increase your standards. From there, moving by small step increments is the way to go. Obviously, it's easier. It helps not tackle everything, because trying to tackle the whole problem at once can be discouraging. And it helps grow your understanding of the data set progressively also, because even if it's your own data, even if you've been collecting this data, there's always something to learn more about the data set as you use it. Account for final scope in the initial assessments. I mean, like you need to plan large. Some of you might be aware of it, but if you're not, take in consideration the IT infrastructure you'll need around it, because it is, as I showed in the previous page, it is a very large part of any ML project. If anything, an ML project is probably more of an IT project than a mathematical project. And also another thing that goes with there is that unlike regular IT project, or unlike agile user interface and you need a button, you know that you can create a button in whichever language you have. But when it comes to ML projects, you don't necessarily know if it's possible, and you don't know if it's possible. You don't know which way is going to be the best, or even if one way is going to be possible. So you need to account for that. Manage expectation, also a big one. Expectation for the client, because there's this, we always said there's this buzzword of AI. Everybody is thinking that like the next Terminator is out the corner and will be ready in 2021. But ultimately, you need to keep things reasonable. And also in link with this, having, starting with the easy stuff first. Make sure everyone understands that you're not developing a science robot. And also the other way, including your own expectations. So manage or define how far you want to go. Because, well, first, you need to start at the right place, and then it will allow you to optimize or, actually optimize your resources. So for example, we have this big LSTM that is running predictions for predictive maintenance. So we're basically, using this LSTM or this recurrent neural network to evaluate the state of components. And so right now we're using data every 0.5 seconds because that's the resolution we have. And so we feed in all this huge amount of data every 0.5 seconds. As you might imagine, it grows quite large, quite fast, and we get our prediction. But having clear expectation on the amount of the precision of the prediction we want to make allow us to do tests right now, so that we're testing, well, what if we only feed the data once every 2.5 seconds, or every 5 seconds, or even every second? How would it affect our prediction rates? And on the opposite, how would it affect the training time? Because as you know, like we are training on Azure, and those GPUs are not cheap. And so if for a 2% decrease in prediction accuracy, you get half of the training time, then it's obviously a good gain you get there. And evaluate solution from simplest to more complex. Have a global approach. The idea here is, not to kill a fly with a shotgun. The global approach, what I mean is that there shouldn't be a problem too simple for the AI or data science team. You need to tackle the simple problem first in order to grow complex. Don't try to tackle the problem with the big gun first and then tie up the loose ends with the simple equations. It really has to be the other way. And also a corollary of that is that usually the more complex an algorithm or an approach is, the less explainable it is. And so again, like if we go back to this predictive maintenance example, this LSTM is great. It's detecting pretty much everything we want, but it's an LSTM. And so for those of you who know the principle in deep learning is that it's really hard to explain. It tells you that something's wrong, but what is it? You can't really look into the neural network and understand how all the algorithm decided. And so that's why we go down sort of a branching with this simple, stupid test first. And then as we go down, if it passes the stupid test, then we go a bit more complex, bit more complex, bit more complex. And then at the end, when everything, all the simple tests have passed, then we throw out the big LSTM. And so that allows us to identify simple problems first. So if it's just that a sensor is faulty, well, you detect it first, and you don't have to run all of the training of your LSTM to get that, oh yeah, I mean, I don't know, like that tire pressure was obviously broken because it's been at 0 for a week. Other than that, start collecting data and do something with it. We've seen a lot of, in a lot of places, clients where they had the system, they had everything running, and then they sort of forgot about it, thinking that, you know, I'm collecting data, I'm fine, I'm future-proof. But as you know, the mining industry or the mining environment is very rough. And so there will be things that break down. There will be things that wear up. And so you need to have you need to assign somebody to look at this data, because when somebody, if even simple application have thresholds to see like what's happening, because when someone's looking at the data, someone's using this data, it allows to flag early those defect rather than collecting columns of 0 for years without anyone noticing. Don't feel ashamed to start now. I'm part of this practice community in Montreal that includes a lot of different companies. There's bank, aviation companies. And at first when I joined, I thought I'd be like, you know, the mining guy that obviously is behind because the mining industry is always behind. But I soon realized that obviously we are all in the same boat. Everyone is starting. And even though there's a lot of big words about everyone's doing AI, honestly, in the background, it's often just decision trees and linear regression. So, you know, we don't have to feel small compared to other industries. Get a diversified team. You need people from math, dev, QA, BI. It needs to be complementary. Have the different skill, different opinions on how to approach your problem, and interact with the client. Again, it sort of goes along with this diversified team, but having interaction with the client will give you all those edge cases you want. We have projects internally and externally, so we're developing tools for Newtrax itself and for outside. And in both cases, it's really like having to talk with the client and identify the needs that got us to develop tools that were suited for the client need. I guess it also is in the agile methodology. So making sure that what you develop is actually what the clients want, and again, is not overkill or doesn't do something that you don't need to do. And one last point on this one, for the interaction with the client, for the mining industry specifically, I think it's even more important because as you know, like in the industry, if you don't know your mining, you'll be considered as no one will consider your work. So you need to be close with the client to show that you understand the mining reality, because it's something that is very different from the other industry. So if you just show up with your AI hat and say like, I'm going to solve your problem, let me AI this thing, nobody's going to trust you, and probably for good reasons. And finally, universities are there for more experimental research. You need to get your expectation right about what you're going to do. I know there are people from IBM here, so maybe IBM can develop like the new big revolution in AI. But for a company like us, we cannot tackle new problems. We need to look into what is already there, there's a ton of articles that are out there every day to help your research. And if you need to go further than that, well, universities are the source of that, and there's a ton of funding that is available. And if the open dataset goes on or similar initiatives, then it will really help the university sort of develop the algorithm that the industry will use tomorrow. And so, a short conclusion, I know there's a lot of people in the room, so I'm expecting there are people in all the different part of that trail. If you're on top of Mount Stupid, I hope this talk help you sort of smoothen the curve, as they say these days, and will help you fall down a bit more easily. If you're down the valley of despair, well, I hope it gave you hope. And if you're in the slope, well, please join us in helping the community and really bring forward the application of mining, the application of AI in the mining industry. And so thank you for your attention, and I'll be taking your questions.
Excellent. Well done, Louis-Pierre. That was fantastic. So Heather T, any questions?
Yes, we do have a few. And Louis-Pierre, there were a few comments that people were very familiar with, I think, both the mountain and the valley. So I think you spoke to many people there. The first question, is it a good strategy to use or pay for Azure? Please share experiences.
Well, at first, honestly, we were like, what's this thing? It's so expensive. Like, it doesn't make any sense. We could buy that computer in like two-month subscription. But then, honestly, especially dealing with a lot of sensitive data, Azure comes with sort of the stamp of secure. You know, if you get if you get an audit for security, you can just say like, we're on Azure, and it takes care of a lot of these things for you. And so you don't have to get like the secure infrastructure, the secure communication. It's, you know, the US government use that for the military. And so it gives a lot of credibility to your installation. That, and also like the GPU world moves very fast. And so if you want to get the latest to train your algorithms, it's easier to get like a 1-year subscription, and then the next year get the next best, just updating like this. Whereas if you get the hardware yourself, it's harder to change. And that being said, I said Azure, but we also looked into AWS, and they have exactly the same, like to the cent. They're the same price, same offering. Is to us, it seemed like it's whatever you want.
Okay. How have you been able to build the culture and framework to support Agile for AI projects and product delivery?
Well, honestly, this one, we are still in this process of building it. We have been quite bad actually at following the Agile process. Now we've got a new Scrum Master. Again, in this practice community, I saw this idea of having sort of a two Agile loop, sort of superposing each other, where you get more of the data science part, superposing the loop with the development part. And so you get sort of data science deliveries and then development deliveries that interconnect in the middle. But yeah, I mean, like, it's still a work in progress, I'd say.
Okay, he followed up with your Agile sprints, what is the cadence and expected deliverables per sprint?
Oh, we basically split the big picture in smaller steps. And so, for example, like right now we're working on productivity for the equipments, getting as close as possible to 100% reliability on the detection of those events. And so for all of those, you can always split sort of in deliveries that make sense. And again, I try to split the data science and development into different sort of different concepts, so that you can really get increments. Say like, okay, I want to have my standard production time report. So that is a nice thing that brings value to the client right away, but that is also sort of manageable and in a small portion.
Okay. Rob wanted to know if you could share any experiences of projects that didn't make it out of the valley of despair.
Well, yes, actually, we had developed this optimization thing, because my background for my PhD was in mine planning optimization. And so when I started, we had this crazy idea, like, let's go and create a project to optimize everything for the production and get this shift planning. And so the model was really good. It was a CP model, constraint programming model. It did optimize everything. It was rather scalable, but then we realized that the infrastructure needed to get the whole, like everything you need to do like shift planning is a lot more than just getting a mathematical model to optimize your shift. And so that is still in there, maybe someday, but for now at least it's laying out there.
Okay, and I have one last question. Any thoughts on AI model governance, given the growing number of citizen data scientists?
Sorry? Well, actually I have it.
Any thoughts on AI model governance?
I'm not sure. What do you mean by AI model governance?
Governance.
Yeah. Maybe Daniel. Sorry, go ahead.
Maybe I can clarify that.
Yeah.
Yeah, so model governance meaning that many people in your company might be developing their own algorithms because, the algorithms, as you know, the algorithms themselves are pretty much commodity these days. Mm-hmm. So people can just grab them and run them through some Python code and just throw data at them and develop a model, for example. And, there's different skill sets in terms of people that are well skilled at doing that and people that are just grabbing some Python code and running data through it, which can be sometimes dangerous. So I'm just wondering, if you have any strategies, if that's an issue at Newtrax, because I know it is an issue in other places. How do you manage that, and any thoughts on that?
It's a very good question, and we try to manage it the best we can, but yeah, as you say, like it's a big problem because we have, obviously other people are also doing it, but I got this talk where they were mentioning this problem where, if everything relies on something that is developed by someone else, and like if the data you use is produced by the processing of another department, then all of your models are dependent on the data being in the exact same format all the time. So if that other department will change something, then it will also change your whole process, and you might not even know why. And so the way we've been dealing with that is that we try to use the data as raw as possible for all our algorithms. At least for now, the other departments are pretty good at mentioning when they change something. But yeah, I guess my advice for now is we use the data as raw as possible and try not to get output from other process. But down the line, that's something we'll have to address. But I don't have an answer, a ready answer for that.
Andrew, we do have another question that came in. Do we have time, or should we move on to the breakout?
Yeah, one last question, and then we can go.
Okay. What do you find to be the most common or important business case for machine learning and/or AI? Financial, safety, productivity, resource estimation, or extraction, etc.
Well, I think this one's. I obviously I'd go for safety, just because I think there's a lot of potential in there for these nuisance alarm. Because a lot of the safety applications right now are not doing their job properly, or they could be doing their job much better, just because of right now a lot of it is set on thresholds. So for proximity detection, for example, it's like, well, if my sensor ranges you in this and that, like I give you an alarm, and like these thresholds are very sensitive, and so if they're too sensitive, they'll give a lot of alarms, and then miners, after 4 or 5 false alarms, they won't just probably hit the thing with their wrench or just pull the box out, and so it doesn't work. And on the other sense, you want to make sure that when it is a true alarm, you're actually there and you can actually make the call. So I think ML has proven to be very good at that, finding like the sweet spot where it just work and sort of understand in between. So yeah, I would say safety.
Okay.
Excellent. Well done. That was fantastic. So I'll just share my screen to run through. We're going to go into another exercise.